Hello everyone, welcome to the next lecture in my playlist, a course on data structure. I'm RVD and it's really glad to see you all here. Now before we move ahead, I hope you people have subscribed my channel. If you have not yet subscribed my channel, then do subscribe. You can see the subscribe button right down there and also hit the bell icon so that you'll be able to get all the alerts for my forthcoming videos. Let me also tell you about my overall playlist. So currently there are three playlists which I'm running. The one is the current video will be getting uploaded in, that is a course on data structure. You can see the previous all videos also if you have not yet explored. There's one more playlist that is placement interview questions on data structure. So there I try to create small videos which will try to focus on very fundamental and very important concepts of data structure. So it will be useful for preparation of the technical interviews, as well as if you want to brush up your data structures with short videos, even that will be a good option. Along with that, there is one more playlist that is placement interview questions on C programming. Okay, so that also contains wonderful videos. Currently it is getting built. You can see some few videos already being uploaded. Those videos are also very short videos on fundamental concepts, very important for preparation of the technical interviews, as C programming is one of the very important subject which is being asked. Along with that, if you wish to prepare your C programming, you're going to find that playlist really interesting. So I appeal all of you to do check the other playlist as well and do explore the videos in those playlists. So let's move ahead with the today's video. So the topic for today that we have is working of priority queue, part 1. Now part 1, as in the previous video, if you remember, we've understood that there are multiple types of priority queues: priority queue with normal insert and priority queue with normal delete. So out of that, we've already had implemented priority queue with normal insert, and that is what we call it as part 1. So now in this video, we will be looking at the working of that particular type of priority queue. So when we say priority queue with normal insert, the insert will be done as per the arrival of the elements. So in the sequence the elements are getting arrived, they will be stored irrespective of their priority. Whereas obviously, because it's a priority queue, and as we have already assumed that we'll be working with descending priority queue, it has to delete the highest priority element. Then in this scenario, it becomes a job of delete function to find the maximum and then delete that particular element. It obviously would create a gap, then the shifting of elements is required. So all these things which we have implemented in the previous video, you would be able to understand its functioning or how it works in this current video. Okay, so let's start. So let's start with an initial queue. We can see here the max is being considered as 4. So we've got 0 to 3 as the indices of the elements. So let's start with insert. Okay, so I have insert 5. So obviously what will happen is your R will be incremented in a normal fashion and your 5 will be inserted. So R is getting incremented and 5 is inserted. Okay. Then let's look at one more insert. So let's say insert 8. So R will be incremented and 8 will be inserted in the new position of R. Similarly, let us try more inserts. So insert 4. R will be incremented and 4 will be inserted. Insert 7. So again R will be incremented and 7 is inserted. So as I just now said, insert is normal as in insert will be as per your simple queue. It is just placing the elements as per their arrival. Okay, now let us try to do delete. So you obviously have to find the maximum and you have to delete it. Okay, so let's see how exactly we can go about deleting the maximum element. Okay, obviously we need to find it first. Now there is a very typical logic for finding the maximum. So the first element is considered as max. So you can see your queue of 0 will be considered as max, and this is considered as its position. So you can see that max is 5 and position is 0. So for loop starts from 1. So let's look at I equals 1. It compares the element at 1, that is 8, with max. Is q of 1 greater than max? Yes, true. So max becomes 8 and position obviously will change to 1. So my current max is now 8. For loop continues. So for I equals 2, q of 2, which is 4, is it greater than max? False, it's not. So there will not be any shifting. Then obviously I becomes 3. q of 3, which is 7, greater than max is again false. So that will not be also considered. And finally, when the for loop ends, my max remains 8 and position obviously remains 1. So we've identified that this is the final max, okay? And this is the element which we need to delete. So obviously, as you know that that particular element will be kept aside. You know, generally we store that element in Z. Here we don't even require Z because it is already stored in a separate variable max. Now we need to do the job of shifting because it has created a gap. Okay, so let's see how can we remove that gap by shifting the elements. Now obviously I need to start shifting from this, that is the position. Okay, so my for loop, rather, if at all you visualize, it should start from pause and it shouldn't go up to R because I don't want anything to be shifted at R. So it should obviously be up to R minus 1. So if you see here, position is 1 and R minus 1 is 2. So in short, my for loop should go from 1 to 2. Okay, so you can see for I equals 1 to 2. When I is 1, Q of 1, that is Q of I, should get Q of I plus 1. So obviously this shifting is required here and that will happen with this. Next, your I obviously will become 2. So Q of 2 is supposed to get Q of 3. So that's going to happen. And finally, your for loop will get over. So your R will be decremented because one element got lost. So R will be decremented and delete is obviously will return the maximum, which is 8. So that's what you would be able to see as a deletion. So currently the maximum element got deleted as it was expected. If at all you think and go ahead, you obviously can very well sit back and try to go ahead with more deletes. So next delete will obviously take 7 as the max and it will delete it. Obviously no shifting will be required because that's the last element that logic will handle and simply R will be decremented. Then the next will obviously delete 5. Suppose there are two 5 when I'm deleting the maximum and 5 happens to be maximum, suppose. So first 5 is here and the other 5 is somewhere down the lane. Now what will happen is when the first 5 becomes max, the letter 5 cannot change that max because the letter 5 is not greater than 5. And hence the earlier 5 will be considered as the max and that will be deleted first. So as what we want is same priority element obviously should follow what? Should follow FIFO. So can we say it is happening? Yes, it is happening. Because obviously they are being stored as per their arrival and the first element obviously is considered as max first than the latter element. So they would follow FIFO. Fine, so I hope you people have understood the working of the priority queue part 1, that is using normal insert. Fine, so if you have not seen the previous video, you obviously should see that. So there you will see the implementation, the coding, and this has completed the working. Fine, we have another type of priority queue, that is priority queue with normal delete. Okay, so in the coming videos, we will also implement that normal delete type of priority queue and we'll also come up with the working of that. Fine, so obviously be with us for that. You can check out the videos that will be also uploaded soon. So that's it for this video. Thank you and happy learning.